On today's Emerging Tech Horizons podcast, ETI's new directed energy supply chain study, how we can actually build the laser weapons and microwave weapons that we think we can build today. Hello and welcome to the Emerging Tech Horizons podcast. I'm Arun Serafin, Executive Director of NDIA's Emerging Technologies Institute. Today's episode is being recorded on the day of the release of ETI's latest report, a supply chain study called Directed Energy Weapon Supply Chains, Securing the Path to the Future. The report assesses the current state of directed energy weapon supply chains and seeks to educate the broader national security community on potential steps to improve their development, health, and resiliency. Joining us today are Rebecca Wostenberg, ETI's very own research fellow and the study director, along with Mark Neice, the Director Emeritus of the Directed Energy Professional Society. Thanks for joining us today.
Thank you, Aaron.
Glad to be here.
Here's the study. So let's dive in. Before we dive in, I want to give the audience a little context. So Mark, you've worked in the directed energy field for a long time. To help set the stage here, can you share a little bit about the history of directed energy weapons and where we are today?
Thank you, Arun. So the origins of the directed energy community begin back in the 1980s with the Strategic Defense Initiative. At the time, those technologies were largely focused on megawatt class gas and chemical laser systems, as well as tube technology for our high power RF capabilities. And those systems, although very effective, were large and were not fieldable in a reasonable pattern. In the 2000s, we saw the emergence of solid state laser technology, largely driven by the commercial industry, the commercial cutting and welding industry. And so the DoD has been able to leverage that investment into that commercial technology, and we see that moving forward. Similarly, in the 2020s now, we see the emergence of solid state technology in the high power RF field. And so that is very exciting because we're looking at the same migration of technologies from old bulky systems now to newer, more efficient systems that allow us to now look at fielding these capabilities onto the platforms of choice, the ships, the mobile vehicles, and the aircraft that are of interest to the Department of Defense.
So there's always been a lot of discussion, a lot of promise going back to the 80s, maybe even before, about these kinds of systems, both the high energy laser side and the microwave side of it. But what you're saying there is the technology really might be there at this point.
At this point, the technology is there. And we are moving forward. We have several hundred kilowatt laser systems that are now being developed and deployed. And we have high power RF in the gigawatt class range that are being brought forward into useful technologies for multiple mission sets within the department.
And for those of you who want to learn more about directed energy weapons, check out our recent Tech 101s on both high energy lasers and high power microwaves to give you sort of a layman's understanding of how the technologies work and their implications for DoD. So with that background then, Rebecca, can you share why ETI decided to launch a study of the supply chains of this area and what the goals of the study were?
Sure, absolutely. So back when ETI was founded in 2021, we kind of looked across the defense emerging technology space and looked for where are the places that we could have the biggest impact. At the time, given current world events, there was a lot of work being done on supply chains across the board, inside government, outside government, et cetera. But we noticed that there weren't a lot of organizations outside of the government doing much on the defense emerging technology supply chains. Really kind of putting yourself in the future and saying, all right, if DoD is going to actually deploy these systems, what are the supply chains that you need in place now in order to actually field these at scale and affordably. So given that, we decided to go ahead and launch the Emerging Technology Supply Chain Study, really with sort of those two goals in mind that you mentioned earlier. The first is to assess the current state of defense emerging technology supply chains. And second is to provide actionable policy recommendations for their development, health, and resilience. We don't just want to admire the problem, we actually want to offer actionable solutions. Solutions to government, to industry, to academia. We've got a lot of different players in this field that all need to come together to help address this issue. We decided early on to focus on sort of 4 aspects of the supply chains. There's a lot of ways you can kind of slice and dice supply chains. But we decided to focus on first, critical raw materials and goods. Second, manufacturing base and workforce. Third, supply chain security and vulnerabilities. And finally, fourth is international partnerships and allied nearshoring.
And I mean, I guess what you're saying is both on the directed energy side with this report and previously on your hypersonics effort, the system right now is funding to the point of production of, let's say, prototypes.
Exactly, kind of onesie-twosies.
And it's a very different supply chain that's required to produce onesie-twosies as opposed to full deployment, full operational capability. And so that's where you dive in.
Yep.
As you undertook these studies then under the banner of ETI and NDIA, how did NDIA members get involved in this? And even more than that, how did our partners in the government get involved?
Yeah, absolutely. So we decided early on, we're here at ETI, we're in a really unique position as part of NDIA, and we have access to this incredible expertise in our member base. And so we really decided to set up our methodology for the study to leverage that. So I'll walk you through sort of the steps that we took to do that. First, we partnered with one of our academic members, the University of Maryland, and their Supply Chain Management Center, where we had a team of professors and graduate students that really came together and helped us kind of build the foundation for our research, to help us start to identify, just looking at open source information, what are the key vulnerabilities? Who are the key players in this field? Just kind of give us that foundation to start from. They did fantastic work. From there, we then worked to bring together the key stakeholders in this realm to conduct a series of working groups and numerous interviews. We also worked very closely with Mark Neice here at the Directed Energy Professional Society. Mark was invaluable in helping us, especially to identify those key companies. He obviously has a wealth of expertise that he brought to the report as well. So really, it was a lot of the partnerships that really give the strength to this report.
And those companies, I assume, were up and down the supply chain. So the biggest guys who I think of as systems integrators or prime contractors, and their sub-tier suppliers, and even the academic researchers feeding in clever ideas, intellectual property. So the whole gamut. Okay.
Exactly. Really, our goal is we wanted to reach out to as many members and non-member companies as well, because not all of them are NDI members, but bring them together to really bring in that expertise to dive deep into the issues. And really, a lot of the key themes, the key takeaways that came out of those conversations really fed into and formed the report itself. We combined the work the University of Maryland had done with all of these key takeaways from the working groups, the interviews, all the outreach we did. And government was a big piece of that as well. We worked very closely with different offices there, both to get their expertise, since they are experts in this, but also we want it to be a useful product. So we want to make sure that we're focusing on the areas that are helpful to them as well. So that's kind of how we pulled the government in. And then in the kind of the final piece of how we worked with members and the like is we had, once the report was drafted, we submitted it to a peer review committee that we had put together. And that's really, it was made up of former senior government and industry officials that can provide kind of that high level guidance when it comes to especially the policy recommendations. And then we also submitted the report to a group of external reviewers that have deep technical expertise to ensure technical accuracy of the report as well.
That's great. And after all that, and then with some assistance from NDIA's marketing communications team, you got this slick report that's coming out today. And then you're doing a rollout event in partnership with our meetings and divisions folks with the live stream, which will be available for all our members to look at if they can't see it live.
Exactly.
So that's great. So with that background, then, Mark, one more framing question, I guess, is that directed energy weapons we're claiming they're real at this point. We're ready for scale up. We're ready for production. What would be the implications for trying to implement our stated national security strategies for that kind of directed energy weapon production and integration?
Well, from a DE perspective, the advantage that we see of those capabilities is the extended magazine that it has. It basically is relying now on electrical energy and converting that into photons or electrons for defensive purposes. What we really want to do is emphasize that these complement our existing kinetic effectors. It's not a replacement capability. There are weather limitations and other things from an operational standpoint that we have to play out. But directed energy has a place in the battle space. It is a cost-effective solution. We can help drive the cost of engagement per engagement down with directed energy systems. And the other thing is that we're really looking to relieve some of the challenges on the kinetic supply chains, as well as the supply chain details that we emphasized in this study, the challenges that we see there. So what we're trying to do is show that there's a complementary effect between kinetic and non-kinetic effectors. We leverage a lot of our existing technology that's out there. And what we really want to emphasize is that we are leveraging not only defense industry, but the commercial leveraging capabilities, particularly in electric technology that comes forward. As we develop electric vehicles and those type of things, battery storage, high discharge capacity, all of those things can be leveraged for our directed energy supply chain in order to give us that extended magazine that we're really focused on to give us a warfighting capability.
Yeah, and that idea is consistent with the recently released National Defense Industrial Strategy, where we are looking to expand our ability to tap into broader sets of the industrial base, including the commercial side of it. You touched on an issue about, some people think of directed energy weapons as replacing some other form of, munition or something like that. And what you're trying to, I guess, to say is that, no, it's complementary.
Exactly, it is complementary, and there are cases where it's a good day to shoot with a DE system,
right?
And there are days when it's a bad day to shoot with a DE system. And on those bad days, we still have to have those kinetic effectors, but we can relieve the pressure on our kinetic effector supply chain by using these DE solutions in a cost-effective manner. That takes time and practice. We have to develop the tactics, techniques, and procedures. To get us to that point, we have to expose the warfighting community to those capabilities and how they interact. And that's kind of where we're at. That's the flexion point that we're at right now.
Yeah, and so if I have to think about the mission sets, for example, me as a layperson would say, it seems like the high power microwaves, the high energy lasers be useful in something like counter UAS, counter unmanned systems. Is that right? Or are there other mission sets that make sense at this point?
There are mission sets that we look at. Counter UAS is kind of the entry level that we're looking at. And those capabilities, we don't have a lot of great solutions, cost-effective solutions for the $300 drone that's operating where we don't want it to operate, whether it's weaponized or just with an ISR capability. So that's really kind of an entry point for our DE systems. But then we look at the counter rockets, artillery, mortar, and the counter missile mission sets, As we scale up in power, those become more believable. But I think what you said is really that we can put a lot of emphasis on that counter UAS mission set. That's a near-term threat that we see in a worldwide basis. And I think that those capabilities that we've developed now are imminently capable of countering that UAS threat that we see kind of in worldwide operations.
And then in the distant horizon, probably still those Star Wars cartoons that I used to watch as a kid on the Strategic Deterrence Initiative and all the fantastic things that the lasers were going to do for us from space even.
It could be from space, it could be from airborne platforms, shipborne platforms, ground-based systems. But obviously, in order to counter the effects of the atmospheric conditions that are applicable to our DE systems, put it on the ground, you got to have more power.
Right, right. So, okay, you've convinced me it's worth studying directed energy systems. And so you did the report on the supply chain. So what did you find? And what were some of the, after the findings, what were some of the recommendations and ideas that you think the community should be considering?
Sure. So it's a hefty report. So bear with me. I'll try and get through as many of the kind of key points as I can today. I think overall, the key theme coming out of this is that the current directed energy supply chains, both for ATLs and for HPMs, high energy lasers and high powered microwaves, we have a manufacturing base that is suited for, like you said earlier, just creating onesie-twosies, small numbers of prototypes, and it does that pretty well. However, it is insufficient to really scale up. And so what our report really does is it kind of pulls that apart of why do we face this now, and what are kind of the key areas that especially the government's going to run into issue as they begin to scale up. And I'll try and unpack that a little bit. First, kind of the why. Obviously, these weapons are nothing new, like Mark mentioned earlier. Really, kind of the key reason why you have this very small industrial base, very small specialized supply chains is kind of a lack of consistent government demand signal over the years, and sort of a lack of strategic vision from the government as well. And so that's really the first recommendation we make in the report is you need a consistent, clear demand signal from the Department of Defense for scaled up products. Because that sends that message to industry. And when you have actual dollars flowing and actual programs of record, industry then will go out and make those investments that are going to scale up production. And that's where you're going to get cost savings and things like that.
Because there's a market.
Exactly.
And people will try to claim the market.
Exactly. Exactly. So that's kind of the overall theme of the report. And I'll say that's kind of similar to what we saw with hypersonics as well, with the report that we released last year on those supply chains. So now kind of unpacking the different pieces. So like I mentioned earlier, we've really focused on 4 different aspects of the supply chain. And the first was critical raw materials and goods. So here we're looking at the very lowest levels of the supply chain. It goes without saying that these raw materials have numerous applications outside of directed energy. Rare earth elements obviously have numerous commercial and defense applications, but they're also key for directed energy weapons. And so we included them in our study. So what I'll do is kind of look at 3 specific ones. We cover a lot in the study, and I encourage our listeners to read the whole thing, but really I'll focus on 3 here. So the first is rare earth elements, and this is one that won't come as any surprise to our listeners. Rare earth elements have numerous applications in DE, but are specifically used as doping materials for the gain mediums which amplify light in high energy lasers. Obviously, there's been a lot in the news.
The active part of the laser.
Exactly. There's been a lot in the news about the fact that China really dominates the rare earth market. They don't just mine the materials, but they also process them as well. Then the next piece that I'll talk about is gallium. And gallium, again, is a raw material that has numerous commercial and defense applications, but it's commonly used in the construction of semiconductor lasers, also known as diode lasers. And then on the high-powered microwave side, solid-state microwave emitters for HPMs are also most commonly made of gallium nitride. Gallium is another place where we see Chinese dominance. And I will say for gallium, it's relatively recent dominance. Prior to 2010, Germany, Canada, and Ukraine actually all produced just as much gallium as China did. So it's really within the last decade or so that we've seen this Chinese dominance when it comes to gallium. I'll also say people might remember that last summer, China announced export controls on gallium and then germanium, which I'll talk about as well. In the short term, prices leaped up 20%. Long-term implications, it's going to take time to see. We talk a lot in the report about kind of what those long-term implications could look like. We got a lot of feedback from our different interviewees and such. Some people said, hey, in the long term, it could actually be a good thing, that it will incentivize other countries to restart production if it's too hard to get gallium from China. Other interviewees said, hey, no, what we could end up seeing is something like the 2010 rare earth element export controls that China put on, where you saw companies that require the material actually moving their manufacturing to China to have easier access. So really only time is going to tell the implications of these export controls. And then the third raw material that I'll talk about is germanium. It's one of the primary materials used in infrared optics. And here you have kind of a similar story to gallium, where the US is very reliant on China. China also put the export controls on last summer as well. So really you've got these kind of three key raw materials for directed energy that are dominated by China.
Is that dependence on China going to be a theme that you're going to be hitting? Okay.
It is, very much so. And I think it's most obvious at those lowest levels of the supply chain. And I'll say sometimes it can be challenging, especially, I believe it was germanium, that the supply chain has many links through many different countries between China and the US. And so sometimes it's not clear where the original source is. And so that's one of the challenges that we also highlight in the report as well, is trying to really illuminate the supply chain and figure out exactly where everything's coming from so you can help find these different challenges. So that's kind of the first part. And I'll get to all of our recommendations here at the end, because we really tried, like I said, to give actionable recommendations to get at each of these issues. So the second section of the report, chapter 2, focuses on manufacturing-based workforce. And then we also talked about testing infrastructure. Testing infrastructure isn't traditionally considered part of the supply chain, but it is absolutely crucial to fielding these weapons at scale. And it was a common theme that came up in our working groups. So I'll talk a little bit about that. Like I said earlier, overall, directed energy weapons have insufficient manufacturing base. Really due to that consistent demand signal over the years. It's a majority of prototypes, little profit for industry. There's not much incentive to invest or expand supply lines with just very small orders. I'll also say there are some key areas where there are directed energy components that are highly specialized, and the skill needed and the time that goes into each of these components. You have really long lead times, which right now is less of an issue. But if you need to rapidly deploy these systems, the government's going to run into some real challenges here. Then on the workforce and testing infrastructure side, we had some really interesting feedback from our interviewees and working group participants. So for testing infrastructure, you really face insufficient testing infrastructure. And here it's not so much about the number of testing facilities that are out there, but it's the regulations that are required.
So where am I allowed to test a high energy laser system?
That's a great question, Mark.
Yeah, so right now we're very limited. Above the horizon tests are limited to 2 locations in the continental United States. The White Sands Missile Range and a high energy laser test facility there. for above the horizon laser engagements, and then off the coast of California and San Nicolas Island in the warning airspace that's out there, the protected airspace. Again, they're centered around protected airspace where we don't have a lot of air traffic that's there. And we also have to build into the policy choices of illumination of spaceborne assets.
So that's the regulations you're
Exactly.
talking
That becomes some of the policy. We've had some recent changes within the policy that has opened up the opportunity for us to increase our test capabilities. We're in the early days of testing those policies out into actual practice and getting good information. But again, it was a long time coming for us to be able to get to that point where we can do these type of testing. Similarly, with our high power RF systems, again, we're limited to a couple of locations, military installations with highly protected airspace above them that allow us to propagate above the horizon to do that. There's a few more opportunities with our RF systems outside of White Sands. We've got human proving grounds. We've got some test capabilities up at China Lake. But again, it's fairly isolated and insulated from the outside world because these do have an effect on both our commercial transportation capabilities as well as many of the electronic signals that are operating out there on a daily basis, to include our cell phones and
Right.
The internet services that we
Right.
provide nationwide.
And Rebecca, you're mentioning workforce as well.
Yes. Yeah, for workforce, again, we face a challenge where there's just not enough people when it comes with the specialized skills in the various subcomponents. And it takes time to train people up. It's not something that happens overnight. So this is something that needs a lot more work. And there has been some really great work done in recent years to try and get at this issue, especially with the Directed Energy Professional Society and a lot of other organizations around the country. People are starting to recognize, hey, we are going to need to train up more people to build up the strong workforce to support deployment of directed energy systems. And in the report, we outline a few of those. Obviously, there's plenty more that I'm sure we didn't get to in the report, but we give a lot of examples of some successful work that's being done on that side. And also on the workforce side, when it comes to directed energy testing, since it's a different kind of testing than the kinetic testing that the range personnel might be used to. So having the appropriate training for that workforce is really another crucial piece that we talk about.
Because it's different to blow something up than to burn it out of the sky or something, basically.
And as Rebecca points out, it's an education process. And so, we've got to train the range folks on a different type of testing methodology. We have to develop the workforce. The university studies in those areas are limited, and they're largely driven by, there's probably a dozen high quality research professors in each of these technical areas spread across the United States. We know where they are and the universities that they support, but it's not a broad structure across our educational system. And so it's very focused, and where those focuses are where we make investments in research grants, in internships. Industry does the same thing, as well as the government investments to try and bring that workforce development forward. And I'm pretty proud of the fact that the Directed Energy Professional Society has a very high success rate of bringing in people to our workforce, the DE workforce, although albeit limited. We're talking about a dozen and a half per year that come in to replace some of those people with a lot of experience, like you pointed out earlier, guys like me that have been around for a while.
It doesn't sound like too much of a stretch, though, right? To come and work with lasers and blow stuff up.
No, we get a lot of people that are very interested in the physics of the effects of directed energy systems. Getting them to work on the component technology and some of the other things that get us to that point where we can create those effects takes a lot of specialty skills as well.
Join us on the next episode where we continue our discussion with Rebecca and Mark on the directed energy supply chain study. With that, I want to thank everyone for joining us again for another episode of Emerging Tech Horizons, and take this moment to let you know about some upcoming events at the Emerging Technologies Institute. We have our monthly Tech 101 series, and we'll have one in a couple of weeks on digital supply chains, and look on our website to see that whole series of our Technology 101 educational series, which are intended for introduction to complex topics to the layperson and to provide an understanding of the importance of those technologies to the Department of Defense. I want to put in a commercial for our second annual NDIA Emerging Technologies Conference. It's going to be held August 7th through 9th, 2024 at the Washington, D.C. Convention Center. Last year's event last August was a great success. We had speakers like Indo-PACOM Commander Admiral Aquilina. We had the Deputy Secretary of Defense, Kathleen Hicks. We also had Undersecretary LaPlante and Undersecretary Hsu and a host of others. Completely sold out, registration, sponsorships, exhibits, so don't be late. Look for announcements regarding our keynote speakers for this upcoming event, as well as when registration will be opening and opportunities for exhibitors, sponsors, and even for NDIA members to present their work at the conference. Thanks again for joining us in this week's episode of Emerging Tech Horizons. I want to give special thanks to Melanie Yu and Daniel Park for producing this and all of our podcasts, and hope to see you next time on Emerging Tech Horizons.